Now let's do something crazy. We rotated this, but let's try following it up with a stretch. It could be shrinking it, taking it all the way to the negative side, or maybe just stretching it. So what does it mean to stretch this? Just multiply it by a number, right? Let's just call that number r prime. Okay, so let's write these equations, but we will not use these names anymore. We'll just anonymously write them down. So let's just write it down with the multiplication factor of r prime. So we are scaling it by r prime. R prime can be positive or negative. So we have a r prime cos phi minus b r prime sine phi, and a r prime sine phi plus b r prime cos phi. Now the reason I did it is because there is something very interesting about this. R prime cos phi, R prime sine phi, they look very similar to these things. Am I right? Of course. So that means these things can actually be treated as a different coordinate. Okay, a separate coordinate in the plane. So let's name these things. Okay, so let's just call it C is equal to r prime cos phi, and D equals to r prime sine phi. So all we did was take these rotations and stretch them by a factor of r prime, and now we will rewrite this with these new names. We will get, so this is 1 and 2, we will get 1 as AC minus BD, and 2 will give us AD plus BC. Does this remind you of anything? It should remind you of complex multiplication. This is what we got when we multiplied A plus BI and C plus DI. We got AC minus BD plus I AD plus BC. And so therefore a complex multiplication causes a rotation of the coordinates by an angle phi, and if we are considering C and D to rotate AB, then it rotates AB by phi and stretches it by r prime. And if we consider it the other way, then A and B are r cos theta and r sin theta. So that would mean that C and D are being rotated by an angle of theta and are being stretched by r. So this is why we interpret the complex multiplication as a rotation in a certain plane, and we take each of these A and B, C and D to be Cartesian coordinates, and so we can plot them. So we will get a B, we will get a C and a D, and when we multiply them, A and B will rotate and stretch. And same for C will also rotate and stretch, and they will end up at the same point because this is symmetric. And so that is how we get the geometric interpretation of the complex numbers. We can see that they remain geometric numbers, and simply the difference between them and real numbers are that they are two-dimensional. They live on a plane, but a real number will live on only this line.